Hey guys, so today we're going to be going over geometric series. So let's get right into it. So geometric series are the ones where you multiply by the same number every single time, or you have a common ratio. In the last video, we talked about arithmetic series where you had a common difference. This time, we have a common ratio. Now, this is the only infinite series you're allowed to actually add up, but only if the ratio behaves, and we'll get into that later in the video. So now, like I said, a geometric series has a constant ratio r, and that means that each term equals the previous term times r. So there's obviously a constant ratio here. I'm multiplying by 2, multiplying by 2, and multiplying by 2. So our ratio right here is r equals 2. So that the formula, it's pretty straightforward, but it's just this first term divided by the second term, and 4 divided by 2 is 2, and boom. So starting off, we're going pretty easy. Now, this is where it gets a little bit more complicated than arithmetic series. In arithmetic series, we didn't have a care if it was finite or infinite, but now there's two examples. You use the finite formula when r is not equal to 1. So a1, 1 minus r to the n over 1 minus r. Okay? Now, infinite only if the absolute value of r is less than 1. So, it would be a1, the first term, over 1 minus r, which is the common ratio. Now, you have to determine whether it's infinite or finite or infinite, but these are the conditions on when you use each one. Okay, so now let's go on to our first problem. And if you're a little bit confused, we'll go through each one in depth as we go through the video. So let's go to our first question. Find the sum of the first 5 terms of 3 plus 6 plus 12 plus 24 plus 48. Now, these are 5 terms. We can add them up, but we're starting off easy, so we're going to try to use the formulas that we just said. So first term. Let's write down our first term. Let me use blue. So our first term is 3. And then our ratio is 2, right? Each term doubles. So 2. And we can use our formula 6 over 3 equals 2. So that's our ratio. And now, how many terms are there? 5, n. So the number of terms, right? N. So now we have to determine, is this a finite or infinite series? Well, it stops, right? It just says find the first 5 terms. It doesn't go on to infinity, right? So we're going to use the finite formula, which is a1 over 1 minus, a1, 1 minus, oh my god, I can't even talk, over 1 minus r. Okay, so this is our formula, and r cannot equal 1, right? Otherwise, the bottom's going to blow up. So now that we have our numbers that we know, this is going to be simple, right? We can now add what we do know. So a1 is 3, so 3 times 1 minus, ratio is 2, n is 5, over 1 minus 2. Okay, great. So now let's try to compute this. This would be 3 times 1 minus 32 over minus 1. And eventually you would get 3 times 31, which is 93. So the sum of the first 5 terms is 93. And you guys can check that. You can add these all up and you'll see you'll get 93. Now, here's our next example. It's a little bit harder. So we're going to say, determine if the sum converges, and if it does, find the sum. Okay, so let's determine if the sum converges. Well, the first term is 8, so let's just write that down. A1 is 8. The ratio is what? Well, remember what it was. It was A2 over A1, so this would be 4 over 8, which is 1/2. So careful. This is a lot of mistake people make. They put 2, but you're halving it. You're not doubling it. So the ratio is 1/2. Now we have to check the condition for infinite geometric series, right? Because this goes on forever, doesn't it? 8 plus 4 plus 2 plus 1/2 plus 1/4 plus 1/8 plus 1/16, and so on and so on and so on, right? Eventually, actually I won't spoil it for you, but we'll see. It's going to go on forever, so we're going to use the infinite geometric series. So if you guys remember, the infinite geometric series was a1 over 1 minus r only if the absolute value of r is less than 1. Okay, so now you guys can see obviously 1/2 is less than 1, so we can use our infinite geometric series. So all we have to do is just plug in now. So a1 is just 8 over 1 minus the ratio is 1/2, so it's just 8 over 1/2, which is 16. So it converges, right? It converges to 16. Converges to 16. Now why? Well, let's think about it. 8 plus 4 plus 2, you're saying, okay, this goes on forever. How the hell is it converging? Well, if we keep going, it'd be 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1 over 32 plus 1 over 64 and so on. Eventually, it's going to get so close to 0, right? It's not going to matter anymore. Right? It's plus 1 over 128 plus 1 over 256, right? These are such small numbers. It's like a negligible amount. It's not going to make a big difference. All right? So that's why it converges, and that's why you only use this if the ratio is less than 1. You use this formula if it's like a finite set amount, like, okay, find the 5 terms. Easy. Find 7 terms. Okay. Find 2 terms. Easy. But in this one, it doesn't tell you how many terms. It goes on to however many infinite terms. But our ratio, 1/2, 1/2 is less than 1, so we can use that formula. Now, here's the hardest example we're going to do today. An infinite series has sum 10 and the first term 4. Find r. Okay, so again, let's write down what we know. The first term is 4, and then the sum is 10. Well, they tell us it's an infinite series, so let's use our infinite series formula, which was s equals a1 over 1 minus r. Now, the sum, so s is 10. We can write that down, s equals 10. Now, we don't know what r is, so now this is going to be, I feel, fairly simple, just simple algebra. So it'd be 4 over 1 minus r. We don't know what r is. So 10 minus 10r equals 4, minus 10r equals minus 6, r equals 6 over 10, or 3 over 5. Now, a lot of people might think, okay, 3 over 5, that's the answer, boom. No, you have to check the condition. So the absolute value of r is the absolute value of 3 over 5. Is this less than 1? That was our condition, and yes, it is. So that means r equals 3 over 5, and it's a valid answer. So, this is a question a lot of people get wrong. If somehow we got 5 over 3, people would still circle it, but they didn't check it against that condition that I mentioned in the very first slide. If it's not valid, then this infinite series is quote-unquote illegal. So, geometric series, in conclusion, let's do a quick recap. Multiply by a common ratio r. The finite sums always work. The infinite sums only work when this condition is true. And yeah, that's pretty much the foundation. Next video we'll go over convergence tests. When it's not geometric, maybe we'll go over some more arithmetic series. But thank you guys so much for watching. If you have any questions, leave them in the comments below. If you have any feedback for me, also leave them in the comments below. As always, if you like the video, please consider liking, subscribing. It really does help out. And yeah, I thank you guys so much, and I'll see you guys in the next video. And Happy New Year, by the way.